All right, so the last part here, we're going to have to draw a triangle for these simply because if you look at this, you're taking the inverse sine there of 3/5, and 3/5 is not in the inner circle. So let's draw out a triangle. And I'm going to use, this is my angle here. When I think about 3/5 there, 3/5 is your opposite over your hypotenuse there. So if you remember SOHCAHTOA stuff, sine is equal to opposite over hypotenuse. So it's going to be my 3/5 there. So opposite of this angle is 3, and then my hypotenuse is up here at 5. So I can use my Pythagorean theorem because I'm looking at cosine, and cosine is going to involve adjacent and hypotenuse. So I need to find um, this bottom one here, this one that's blank. So I'm going to use the Pythagorean theorem to do that. That's a squared plus b squared equals c squared. So that's 3 squared plus b squared equals 5 squared. So it's 9 plus b squared equals 25. Subtract 9, you get 16 squared of b there, and square root of 16 is plus or minus 4. But we're doing this positive 3/5 there, so we're just looking for the positive values when we're putting them in here, so we're going to put a 4 here. So now going ahead and generating this, looking at that, cosine is your adjacent over your cosine is your adjacent over your hypotenuse. So the cosine, I'm going to call this theta in here, this whole thing is theta, is equal to 4/5 here because this is my adjacent, this is my hypotenuse. So I simply get 4/5. So again, we can use a triangle here to set these up. So I'm going to do part B down here now. Triangle, angle. So tangent, SOHCAHTOA, is your opposite over your adjacent. So 5/12 here is going to be opposite over adjacent. So my opposite from this angle here is 5. My adjacent from this angle here is 12. And I need to find my hypotenuse. So I can use my Pythagorean theorem again. I can say 5 squared plus 12 squared equals c squared. And then that's 25 plus 144, which is 169 equals c squared. Take the square root, and c there is 13. So now I'm just going to put 13 up here. Since we're dealing with sines, so we go sine of theta is equal to your opposite over your hypotenuse. And our opposite there is 5, and our hypotenuse there is 13ths. So we get 5/13. And then we got the cosecant of the inverse cosine of 7/25. Again, I'm going to draw a triangle here to kind of give us an idea of what's going on, help us get our other value. So cosine, using SOHCAHTOA again, cosine is equal to my adjacent over my hypotenuse. So looking at this angle right here, I'm doing adjacent. Adjacent is down here, which is 7. And my hypotenuse there is 25. So now looking at these, we can go ahead and determine what the cosecant is. So cosecant of theta there, if you remember what cosecant there is, it's 1 over sine. So we can set that up. So 1 over sine theta. But sine theta there, we know what sine is. Sine is equal to your opposite over your hypotenuse. And my opposite here, in this case, we don't have yet, so let's find that. Let's use our Pythagorean theorem to get our opposite. So we've got a squared plus b squared equals c squared. So 7 squared plus b squared equals 25 squared. 49 plus b squared ends up giving us 625. So b squared ends up being 576 when I take 625 there minus 49. Take the square root and b ends up being 24. So my opposite there is 24. So you can either think of this as 1 divided by the sign there is your opposite of your hypotenuse, which is 24 over 25. But then 1 divided by 24 25ths is the same thing as 1 times the reciprocal of that second value, which is 25 24ths. Which then just gives us 25 24ths as our final answer. Or some people, when they look at this, think, oh yeah, I just got to flip the sign ratio there. So if the sign ratio ends up being, what do we say that was, 24 25ths, we can just flip that and get 25 24ths. So whichever way you want to do that, it's still going to end up giving you the value of 25 over 24. All right, so you get to do page 557, numbers 2, 4, 10, 12, and then 16 to 34 evens. So have at that.